Hello, is it audible, right? Hello. Right now. Right now. So isomerism, structural isomerism, stereo isomerism, same like organic compounds. In organic compounds we discussed, right? Yes, no. In organic compounds, structural isomerism means compounds which are having the same molecular formula but different in their structure. What is the structure? Either it would be chain, position, functional, metamerism, atomerism, or ring chain isomerism we discussed. And in case of stereoisomerism, we discussed conformational isomerism, configurational, geometrical, and optical. But whereas in this case, almost all similar, but the structural isomerism and stereo, geometrical, and optical we'll discuss here. So in case of structural isomerism, I told you in the last class, right? Linkage isomerism, right? So same formula would be same. The isomers which are having the same molecular formula but different in their bonding patterns, right? In this case, once again, linkage isomerism, coordination isomerism, ionization isomerism, solvate isomerism. So write it down. So linkage, coordination, ionization, and solvate isomerism. So last class we discussed somewhat about linkage isomerism, right? In case of ligands, ambidentate ligands. Ambidentate ligands means what? Right? The ligand which is of the two atoms, two donor atoms. For example, cyanide is there, carbon as well as nitrogen. NO2 is there, nitrogen as well as oxygen, like that. So we'll discuss that. Coordination isomerism, ionization isomerism. So somewhat easy only here. So we'll discuss that. Linkage isomerism. So ambidentate ligands, I told you, right? Isomers which, when formed, ambidentate ligands in different coordinations sites. For example, Tn, it is both carbon as well as nitrogen, both are acts as a ligands right here. NO2. In NO2, nitrogen as well as oxygen. Okay. Yeah, this only. Right. Write it down. This one, solvate isomerism. Okay. Did you write this? Right. In this case, cyanide, carbon as well as nitrogen, both are there. Right. This type of isomerism, for example, in these two complexes, so they'll give like this. So which isomers they are asking? They are linkage isomerism. In this case, nitrogen acts as a ligand, whereas in this case, oxygen. If you can compare total molecular formula, 1CO, 1CO, right? And 5NH3, 1, 2, 3, 4, 5, 5NH3. In this case also 1, 2, 3, 4, 5, 5NH3. And here is NO2 is there. NO2 is acts as a NO2 as well as ONO. NO2, ONO, right? NO2 and ONO. So this type of we are called as, write it down, write the example. ఆన్లైన్ వచ్చినాయి, ఆఫ్లైన్ వచ్చినా, ఇక్కడికి వచ్చినావా? ఇక్కడికి వస్తున్నాడా సార్? ఇక్కడికి వస్తున్నాడు. కంప్లీటెడా? హలో, డన్ అన్న. Sometimes they'll give the compounds, which of the they'll give CO, NH3, taken 5, ONO, Cl2. Like this, they'll give both. Which isomer they're asking, right? We have to say linkage isomerism. Okay, linkage isomerism. Isomers. Linkage isomers. Then next. So how can we differentiate, right? Ambidentate ligands, I already told you, right? So different colors of complexes. This is yellow in color, this is in red in color. Yellow and red. Yeah. So both are the linkage isomers. One is having the yellow color, one is red color. Write it down there. Who observed? George and Sen. George and Sen observed different colors of two isomers. So compounds which are having the same molecular formula but different in the linkage of the ligand. అరే యూట్యూబ్లో స్ట్రీమ్ అవుతుందా చూడండి ఒకసారి. ఒకసారి అందరు యూట్యూబ్కి వెళ్ళి ఒకసారి లైక్ చేసిరంట. ఫోన్ అవుతుందా? లైక్ కామెంట్ చేయండి. ఓన్లీ వన్ ఐఎమ్ ఓన్లీ ద వాచింగ్. వన్ మినిట్ లేట్ ఉంటుంటుంది కదా, 1 minute ఉంటుంది, 30 seconds. ఇక్కడికి అక్కడికి లైవ్కి లేదు, చాలా డిఫరెన్స్. వచ్చేదాన్ని మళ్ళీ ఎందుకు? డన్. So this is like colors are there. So SCN, NCS, right? This complex linkage isomerism. PTCl3 SCN, and they'll give NC SCN NCS. NCS. Both are linkage isomers. Both are linkage isomers. Yeah, remove your నేను చెప్పా ఒక్కరు కూడా ఓపెన్ చేయలేదు యూట్యూబ్. నా 2 నేనే డివైస్ ఓపెన్ చేస్తా. లేదా చల్ డన్. కోఆర్డినేషన్ ఐసోమరిజం రా. So coordination isomerism, so two cation and anion is there, right? So just exchanging of the metal directly, in this case platinum, right? NH34, copper, this is cation, this is anion, right? So now exchange of ligands is a coordination isomers. So it is in this case, so the Cl is coming here and ammonia is going to over here. Simple. Coordination isomerism. Write the example. So if you want, you can write this definition. So interchange of ligands between cation and anionic entities in different metal presence. Right? If you want, we can write it down. Interchange of ligands between cationic and anionic entities. So this is cationic, this is anionic entities. Interchange of ligands. Simple. Interchange of ligands. Coordination isomerism. Second type, linkage coordination isomerism. Interchange of ligands between cationic and anionic entities. Come on, write it down fast. Then write this example. We can take any number of examples, that doesn't matter. Okay. So in the coordination entities exchanging. So structural isomerism somewhat easy only. Only the problem is in stereoisomers. So they are asking the questions. Please write it down fast. Otherwise, take the screenshots. Already it's streaming in the YouTube, so you can go watch later also. Then ఈరోజు కంప్లీట్ చేస్తాను నేను. చాలా ఇంపార్టెంట్ టాపిక్, కొంచెం కాన్సన్ట్రేట్ చేయండి. 2 to 3 వస్తుంది. D and F కాంబినేషన్ ఉంటుంది. దాని ఫిజికల్ కెమిస్ట్రీ కూడా అటాచ్ చేస్తున్నారు. ఇట్ కుడ్ బి ఎనీథింగ్. ఇంతకుముందు ఒకటే చాప్టర్లో అడిగేవాళ్ళు, ఇప్పుడు కాంబినేషన్ ఆఫ్ క్వశ్చన్స్ అడుగుతున్నారు. అది ఈ చాప్టర్ నుంచి వస్తుందా, D and F నుంచి వస్తుందా, పీరియాడిక్ టేబుల్ నుంచి వస్తుందా, కెమికల్ బాండింగ్ నుంచి వస్తుందా అనేది తెలియదు. బట్ ద క్వశ్చన్ ఇస్ ఎ కాంబినేషన్ ఆఫ్, ఫర్ ఎగ్జాంపుల్ ఆల్డిహైడ్స్ కీటోన్స్ నుంచి ఆల్కేన్స్, దీన్ని కూడా చేయొచ్చు. Right. So same that only example, just exchanges takes place. Exchange of ligands in case of cation and anion. Same that only. They just take the screenshot. Hello. Then I'm just moving ahead. Hello, done. Hello. Yes. So ligands are exchanging, it takes place. So chlorine, ammonia, chlorines, like that. So no issues that. Total how many are possible means total coordination isomers are 4. Aura. right? 2Cl, NH2. So just exchanging is takes place. How many ligands we can exchange means total 4. So like this. For example, see Nana, the Cl NH3, right? Both are same or different? Hmm? This is okay, right? 3 Cls, 1 ammonia, right? In this case, this we can consider. But in this case, both are same. 2, 2, right? 1, 2. So here. So first 2 isomers we exchanged, right? Cl4, NH4. సో అందులోంచి ఏం చేసాం, ఇక్కడనేమో ఒకదాన్ని అటు ఇటు చేసాం, అక్కడ రెండింటిని చేసాం. అర్థమవుతుందా? సేమ్ అదే వస్తుంది మనకి. ఇది ఒరిజినల్ కాంపౌండ్. ఒరిజినల్ కాంపౌండ్లో మనకు టోటల్ 4 వస్తున్నాయి. Write it down. If the coordination entities becomes neutral, then it will not considered as a coordination complex, will exist as a free entity of the solution. Cation and anion, then only we can say the complex compound. The coordination entity becomes neutral, then it will not considered as a coordination complex, will exist as a free entity in the solution. This is particularly like these cases, cation and anion, 2 complexes are there. 2 complexes, this is cation, this is anion. If it is neutral, like then in this case, NH3, cobalt, chromium, NH3, Tn. So what exactly happens? Cr, NH3, cobalt. So just exchange of ligands takes place. Simple. Total 2 cation and anion both are there. So exchange of ligands. This is coordination. Easy, na? Structural isomerism somewhat easy, doesn't matter. So linkage, coordination, and right, we'll discuss that is solvate, water molecules just exchanging. Just write the example fast. Done? Hello. Take the screenshot. Otherwise, Avikshit, ఉన్నావా? రామానుజం. Hello, done? Same, ra. What exactly? Cobalt with ammonia, chromium with ammonia. Exchanges takes place. Just take the screenshot, same complex, but we just wrote in the elaborated mode. Find the total number of structural isomers in the given compound. So, how many we can try? Try check. So, no, ఒక్కొక్క exchange చేస్తూ ఉండు ఆటోమేటిక్గా. How can we? 3, 3. అవును రా, చేసే ప్రాబబిలిటీ చూడు ఒకసారి. 3, 3, 3 చేసాం అనుకో. 2, 1. 1, 2, 3. మళ్ళీ 4 చేస్తే సేమ్ అవుతాయి. ఇందులోంచి ఒక 3 అమోనియా ఇటు తెస్తే NO3ని ఇటు ఒక 3. ఇక్కడ నుంచి ఒక 2, ఇక్కడ నుంచి ఒక 2. 1, 1. ఇంతకుముందు ఎక్స్చేంజ్ చేసామా? Find the total number of structural isomers in given compound. In this case, En, oxalate, ethylene diamine, oxalate, right? Just write the number, okay, and try it. Simple. In this case, platinum NH4, Cl, NH4, Cl. So platinum, both the cases, platinum and platinum only, right? Both the cases platinum only, but the ligands are different. So how can we do? 2 here like this, 2 possibilities we will get. Next, ionization isomerism. Ionization isomerism means what? It's very simple, huh? For example, we know, for example, imagine cobalt NH3 taken 4 Cl2. Imagine SO4 is there, one complex is like this, right? So if it is ionization takes place, how many, which type of ions we will get? This total complex, right? Alane untundi kada, it is same as it is, whereas in this case SO4 is coming out. Imagine if SO4 is inside, one chlorine is outside. So it arises when counter ion. Counter ions means these are counter ions in a complex salt itself, right? Potential ligands, right? So the displacement actual ligand with the counter ion. Counter ion means outside ion. Write it down. Just the statement. Write the statement. So let's take the screenshot. Counter ions. Counter ions means complex ions. For example, easy mode, you can say, for example, nickel or cobalt, whatever it may be, Cl4, Br2, Cl6, Br2 is outside, imagine. So now what exactly happens? Cl is not coming out, right? Only Brs are coming out. Now if the Br is going inside, one Cl is coming inside, that is called as counter ions. I'll give you two examples. For example, in this case now, platinum NH3, Br, NO2. So now if it is on ionization, what exactly happens? NO2 is coming out and this total complex is as it is. Yes or no? Right? But in this case, what exactly happened? NO2 is coming inside. So complex which are having the same molecular formula, but when they are going to the ionization, so we'll get the different ions were called as ionization isomerism. Simple. Got it? Anybody having still different or difficulty? Easy, right? Ionization isomerism. So first we discuss linkage, next coordination, ionization. This is counter ion outside. This is cation, this is anion. Counter ions means I told you, right? Which are present in the ionic sphere. So I think వింటున్నావు? అర్థమవుతున్నాయా? ఏమైనా డౌట్స్ ఉన్నా? Shall I move? Online guys, nobody is speaking today. Right, one more example. Write it down. The examples are important. Couple of examples you'll get the idea. So Br is coming inside SO4. I gave you right example. Examples are important. They'll give these two complexes. They'll ask the question, general question, which of the following, which type of isomerism is possible, like that. Phones unte YouTube open chesi pettanడి ఎవరన్నా. ఎవరు పెట్టట్లేదు. చదువుకోండి, అలా లేవు కొన్నే ఉన్నాయి. ఎంత అటామిక్ స్ట్రక్చర్ వస్తుంది. Right. So just solvate isomerism we'll discuss. Just wait. Be in the line. Right. So we are discussing linkage isomerism, coordination isomerism, ionization isomerism. Till now we completed, right? So now we'll discuss hydrate isomerism, polymerization isomerism. Actually, then stereoisomerism in tetrahedral complexes, geometrical isomerism, and square planar complexes and octahedral complexes. So ionization isomerism already we discussed, right? Counter ions, right? This already we discussed. Same examples. So ionization isomers products are different ions in aqueous solution, right? I already told you. In this case, Br is coming out. In this case, SO4 is coming out, right? This is in red color. This is in violet color. Okay? Red color and violet color. జస్ట్ కలర్స్ నోట్ చేసుకోండి. సేమ్ అక్కడ అయితే అర్థమైంది కదా మీకు కాన్సెప్ట్. అంటే ఎలా చెప్తామని చెప్పేసి చెప్తున్నాం, అవసరం లేదు రైట్ తీసుకో. నెక్స్ట్ లాస్ట్ వన్ is solvate isomerism. Nothing but we can say the hydrate isomerism. So here is water molecules. So solvate means what? Water molecules with respect to we will take with number of solvate ligand molecules as well as in the counter ions. For example, H2O is there inside 6. So water, particularly water molecule is we will write. So ammonia as well as water we can use as a solvent ligands. Solvent, ammonia as well as water. Basically, maximum cases we'll use as a water. Okay, now? When water is present as a solvent, the solvent isomerism is known as hydrate isomerism. Write it down. When water is present as a solvent, when water is present as a solvent, when water is present as solvent, that is called as hydrate isomerism. Completed? Done.